have any questions? Good. Who got them? Anybody get them? Yeah? Okay, good. Very good. Okay, so let's say you can do the work right here. Let's say I want to know what 8 divided by 2 is. 4? Did that divide evenly into that? Okay. What about 9 divided by 2?
No.
It doesn't?
It does. Well, it does, but it's like a decimal.
Well, so it divides into it, but not evenly, right? So it has what's known as a remainder. Okay?
Oh, yeah.
So how many times does 2 go into 9 evenly?
4.
4 remainder 1.
I forgot.
Like this is like 3rd grade.
Oh, yeah, it is. So the answer to the division, okay, the answer to the division is called the quotient. All right? Whatever's left over, if it doesn't divide evenly, is called the remainder. If it does divide evenly, does anybody remember what our vocab word for that is? Well, this is still the quotient here, even when it doesn't divide evenly. The quotient is just whatever the answer is. But if I have no remainder, because something divides evenly into a number, what is that called? But there's a word for that.
What is that word?
That's what she's asking.
I don't know what it is.
I'll give you a hint. It's been the same word since 3rd grade.
Oh, wow.
When a number divides evenly into a bigger number, what is that number called?
Even.
Yeah, I know product, but that's multiplication.
Factor?
Factor.
Really? Nobody has any sign of recognition? Multiples are the ones that are bigger. Factors are the ones that are smaller.
I'm sorry, it's been since 3rd grade. We're in 11th.
You've used it. Oh my gosh, are you kidding me? First of all, you've used that every year since then. Second of all, yesterday, the very first thing I defined on your papers was factor. So I don't need, okay, so then that's an excuse not to know the material?
2 days ago? What?
Yeah, it's not. No, it's not.
How is it now? We weren't here.
So you should be caught up. You're almost adults. There's videos online. You could come in and get help.
I was stuck in my house.
No one wants to hear your story, Daniel.
And as soon as I came back,
I
she
cannot even with this.
sit outside and not take the test and just catch up.
All right,
I did that too.
you guys, not the time.
Sorry.
Okay? Yeah. So, I'm going to ask you this, and then I know you guys will believe me that you knew that. List for me the factors of 10. Oh, 5, 2, 1, 10. Is that what you just said? So do you know the word factor? Yes, thank you. Yes. Hey, what's the factors of 9? Oh, so do you know the word factor? Yeah, you do. Okay, thank you. All right. So when something does not have a remainder, we call it a factor, right? Now, we've been using that word, this unit, also to represent what? What have we been using that word to represent this unit? The opposite of the roots and zeros, right? Very good. But in the equation, right? So if I have like 2, okay, then that's a root or a zero or a solution or an answer, right? But the factor that goes with that is x minus 2, right? So we're going to connect the words today. Because if I have a polynomial and I want to know if one of my factors is a factor, that's what we're going to be figuring out based on the remainder. I'm going to say that again. That's what we're doing today. I'm trying to figure out if factors, right, are factors based on their remainder. You with me? Okay. Based on what we've been doing this unit so far, here, okay, how many parentheses is that one going to have when I'm done factoring it? 3. Good, because it's degree 3, right? So what I'm asking basically is if I was going to split this into its factored form, is this one of the answers? That's what I'm asking. You with me? Okay. So I always start by putting my factor here, just like I did up here. Okay. And then look on these ones. Okay. Do you see how when we multiply these things out, this box here never has a like term to combine it with, right? So that's how I know to always start here.
How is that so satisfying?
The-
I feel like coloring it, watching it on
You should get one of those mandala coloring books. I think you'd like it.
Okay.
Yeah. Okay. So if I know that this is x cubed and this is x, what's this? Good. So then what's this? Whoa, 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 whoa. Hold on here. Where is that coming from? Those were the like terms for x squared, right? And those were the like terms for x squared. You with me? So how can I use that and this to help me figure out that one?
It has to be -5.
Why?
Because -5 plus 1 is -4.
You got it. You see what we're doing? Which means what does this top row, this part of the quotient, have to be?
-5x.
Good. Did I give you long enough to figure out my other red highlighted box? So close.
No, it's 4.
6x would have been if that was a positive 1x. It has to be 4x. So negative 5x is what we have, but we want it to be negative 1x, so positive 4. Does that make sense? Okay, so when I remultiplied this and this together to get here, I know eventually these are going to be the like terms that are going to combine to my standard form here. So then I had to figure out that's not a minus, that's like me pointing to it. What did I have to add or subtract from the negative 5x to make it what eventually the like terms will combine to be? Does that make sense? Okay. So then what's up here in my quotient?
4.
Is that what I want it to be?
Yeah. Well, there's an extra box.
Well, I just copied and pasted the same box over and over.
Oh, okay. So the extra box doesn't matter.
Not on this one, okay?
Oh, yeah.
But is that, what do you think? Does that make sense?
Yeah.
So, if I were going to factor these 3, would that be one of the factors? Yeah, because there was no remainder. You with me? Okay, will you guys try this process again on this one? It's the same equation. I'm just checking to see if this other one is a factor also. Okay, so go through and double check here. So that's where I start. Put your factor and your x cubed, and you build it from there. Okay?